Okay, we are continuing on chapter 6, and we are talking about loops. So far, we covered the while loop, for loop, do while loop. We went through common algorithms for the loops, and now we want to talk about random numbers and simulation. Remember, the simulation was early things that we were doing in computers and has advanced a lot. So we simulate real life problems, and then we let the computer to run it multiple times and then figure out the solution, because we as a human might not be able to do that, simulating some huge numbers. So one of the things we want to talk about is the random number. So Java has, and C++, other languages, something pseudo-random. So we cannot do 100% random because we are not a random area, but we can create close to random numbers. So that's what we're going to be doing. So we're going to generate a random number, and then for that, we're going to create an object of the random. Remember, every time we want to use a class, we have to create an object for it, and then we can call it. So this object can have next int, and we're going to go over that, and we have next double for the one with the decimal points. So first we have to import Java util random to be able to do that. Then we're going to create our object. So we're going to create it and we're going to put it somewhere. Now, if I use .next int is going to give me a number for an integer. So from the lowest number that I can have in an integer, that's minus 2 billion, to the highest number that I can have, plus 2 billion, that's the number between these. Generally, that's not what we want. And in your C++ class, if you had that one, you were using the percent to narrow it down. We have a different way of doing it here. For the next double, it's going to create a decimal number from 0 to 0.999999. So it's going to be less than 1. It doesn't get to 1, but it's going to be from 0 to less than that. Now, for the next int, we can potentially put a number inside of it. That's going to generate a number between 0 and 9. So we call it inclusive, exclusive. Inclusive means it's going to include it. Exclusive means it's not going to include it. So if I say 10, it's going to be 0 inclusive, 10 exclusive, meaning that it's going to go to 9, but not 10. So if I wanted to generate 1 through 10, one way of doing it is to create this one and add 1 to it. So if it gave me 0, I'm going to make it 1. If it gave me 9, I'm going to make it 10. If it gave me 5, I'm going to make it 6. So you just add 1 to it. So with this next int, we can have 2 parameters. Again, it's going to start from this, and it's going to go 1 before this. So in this case, it's going to go from 10 to 19. So we don't have to use those percent or anything like that. We can actually do that, but we got to be careful that it doesn't give me the, so if I want from 10 to 20, I have to change this 20 to 21. And we have the same things for the double. So we can do the double. So now we gonna do the die. So I need 6 numbers, but remember, if I do next int 6, it's going to give me 0 to 5. So I have to add 1 to it. I could potentially put, say, 1 to 7, but that's another alternative to doing the same thing. This is another simulation. So how do we find a pi? We have a circle that we throw dot at it, And then we're going to count the number of dots inside of the circle. And divide it by the number of tries. And if you multiply that by 4, we're going to get the pi. So first, we need to generate a number between -1 to 1. That would be -1 to 1. So how do we do that? First, we're going to create a double. That's going to give us a between 0 and 1. Remember, this is 1 is exclusive. It's not going to give me 1. Now I want to go to -1 to 1. If I double this, that's going to give me 0 to 2. And I'm going to deduct 1 from it. So if I have 0 to 2 minus 1, it's going to give me -1 to 1. Some of these things you gotta see it once, you're gonna practice it, and then you're gonna remember how to do it. It might not be easy the first time you look at it. So if we do that, that's the way we're gonna simulate a pi. So we put 10,000 tries, that's the simulation. We're gonna try this 10,000 times, and then we're gonna create our object of the random. We're gonna get the hits, that's gonna be 0. Now we're going to create a for loop. That's the best loop for this one because we know the starting point and we know the ending point. Then we're going to call the next the double generator. We're going to do our formula, and then for that one, and then we're going to get the next double, and we're going to get the y. So we have the x and a y. Now we're going to multiply x by each other, multiply y by each other. We're going to add them together, and if it's less than 1, that's going to be the hit. That means it's inside. So we're going to calculate all these hits. We're going to multiply by 4. We're going to put 4.0 in there to be sure that we're getting the double, and then divided by tries. So it's going to give us something close to pi. It's not exactly pi, but that's the close we can get. That's the simulation we can do. For 10,000 or run of these, we get 3 point, and you run it again, you're going to get a different number, but it's going to be close enough. We're going through the self-check again, get a piece of paper, write it down your answers. You want to think about it without before you run it. So how do you simulate a coin toss with a random class? Again, you don't have to go out there and look for it. You don't have to go there. Just think about it. So we have how many options do we have in a coin toss, and how we do the random number, and how do we simulate it? Think about it first, and then you want to run it, that would be fine. How do you simulate the picking of random playing cards? So in cards, we have two things. We have the face, and we have the, so we can have type, like spade, like heart, and then we can have 1 through 9, or then 10, jack, queen. So we gotta remember our simulation is going to give us some numbers, and that we have to map it. How would you modify dice simulation program to simulate tossing a pair of dice? So we might need the 2 die, a pair of dice, to get the value. So what's wrong with this? How do you generate a random floating point number between 0 and 100? Remember, your double is going to create 0 to 0.99999. Now I want something from 0 to 100. All right, that's going to be the end of this section.